is a section on composite functions, and if you'll look at the top of your notes, there's a definition that personally I think is kind of hard to understand, so I'm going to draw a picture for you that I think will help you understand it. It says if you have two functions, f and g, f of x and g of x, the composite function, and it's designated or denoted like this, f and then like a little o, g, so it looks like fog, and you read that as f composed with g, or you'll just hear me say f of g. And the domain of f of g is the set of all the numbers x in the domain of g, such that g of x is in the domain of f. Okay, what? That's the part that I think is hard to understand. So let me draw a little kind of crazy picture that I think will help you. All right, so a function is like a rule. And when numbers go into a function machine, something happens to them, the rule, and those numbers are spit back out. So let me draw two of those. Okay, and when those numbers are spit back out, they've been changed, and they've been changed by the rule. So here's what you have. You've got two function machines, the G function machine and the F function machine. So we input x's, that's what goes into that function machine, and that is called the domain. All the x's that we're allowed to put in are the domain. Inside that machine, that G machine, is some rule. Maybe we square them, or take the square root of them, or subtract 3, or whatever you do. Okay? It's a rule. And that machine spits out G of x. G of x is the range of G. It's the range. It's what comes out. The input goes in, there's a rule, and then the range comes out. But that range of G happens to be the domain of F, because it's getting ready to now go into that F machine. So what comes out when the rule is applied by the G function now goes in, and it's the input into F. And then a different rule is applied, some rule, and out we have the output, and the output is f of g of x. So when you have two rules, the composite function is the output on the second rule after you've used the output on the first rule as the input on the second one. Think about that for a minute. Study that picture. Okay, so the easiest way really to explain it is by example. So let's look at example 1a. Here we have a function, f of x equals 2x squared minus 3. And then we have a second function, g of x equals 4x. And in part A, it is saying what is f of g of, not of x, of 1. F of g of 1. So what that means is we want f of g of 1. So there's going to be an input here. We're going to get g of 1. 1's going to go into our machine. We're going to get whatever that is. When the rule's applied in the G machine, it's going to come out, and then that is going to be the input into the F machine. So first we need to know what is g of 1. So let me show you how you want to write it. F of g of 1 is equal to f of, all right, now let's go up to g of 1. If I just wrote g of 1 here, I would put a 1 here and a 1 here. And I would have 4 times 1. So f of g of 1 is equal to f of 4. So the 1 went in, here was the 1, it went in, a 4 came out, so now that 4 is going in, and we're going to see what comes out. Does that make sense? So now we need to find f of 4. Well, f of 4 is fairly easy. I go over to my f function, And f of 4 is 2. Take out the x, put in a 4 squared minus 3. 4 squared is 16 times 2 is 32 minus 3. So f of g of 1 is equal to 32 minus 3 is 29. So that's the way it works. So let's try another one. Is that going to be the same thing as g of f of 1? Well, let's think about it. That's as if my machines were then switched. The order was switched. So what that really means is g of f of 1. So I first have to put the 1 into the f machine, so to speak. So I need g of, now we want to go f of 1, so we're going to go back to this function and put in a 1. So it would be 2 times 1 squared minus 3. Or g of 1 squared is 1 times 2 is 2. 2 minus 3 is negative 1. Let me write that step so there's not too much. So it's 2 minus 3. And so now I want g of negative 1. Well, g of negative 1 is equal to, go back to this function now, 4 times negative 1. So g of negative 1 is negative 4. Therefore, g of f of 1 is equal to negative 4. And is that the same as what we got before? No, it's not. They're very different. So the order makes a huge difference. Remember, the input goes into the first machine, the inside function, but its output becomes the input for the second machine, the function machine. Let's look at C. We want f of f. Oh, you can do that. Yes, you can. Of negative 2. What that means is, and I always write it this way, f of negative 2. That means we're going to put a negative 2 into this f machine. You're going to get something out, and whatever you get out is going to go in again a second time. All right, so that would be f of negative 2. I'm doing this inside part. Go back up to your f function. It would be 2. Take out the x, put in negative 2 squared minus 3, which is f of negative 2 squared is 4 times 2 is 8 minus 3, which is f of 5. We can do that. F of 5 is equal to 2. Take out the x, put in a 5 squared minus 3, which is 5 squared is 25 times 2 is 50 minus 3. So f of negative 2 is equal to 47. All right, so it went in the machine, came out, and then went back into the same machine, the answer of the first one. All right, so let's look at D. Here we have g of negative 1, and what that means, I always think it's helpful to write this, is g of negative 1. And it's just like order of operations. You're going to do the inside parentheses first. So we're going to do g of negative 1. So g of, what's g of negative 1? Put a negative 1 in the g function. So 4 times negative 1, which is g of negative 4, and that's equal to 4 times negative 4, which is negative 16. So g of negative 1 is equal to negative 16. Okay, so let's talk about domain. The domain of a composite function, because domain can have some restrictions on it. And there's 2 steps here that we're going to follow. And if you will just follow these faithfully, you'll have no trouble with this. To find the domain of the final composite function, first you find the restriction on the inside function. So the restriction, now there may not be a restriction, but if there is one, you find the restriction on the inside function. The inside function is, in these cases, it's the one that comes f of g. G of 1 was the inside function. It's what we write inside those parentheses here and here. Okay, in our function machine, the inside function is the one that comes first. Okay, so you find the restriction on the inside function, and then second, You go ahead and you find the composite function. So you finish the algebra, you find the composite function, and check for further restrictions, which there may or may not be. Okay? So let's take a look at doing one of those. Let's look at example 2. It says, suppose that f of x is equal to x squared plus 3x minus 1, and g of x is equal to 2x plus 3. Find the following and then find the domain of each composite function. So in A, we want to know what is f of g. Now you notice there's nothing written after that. It's just f of g. There's no number. So that means f of g of x. Okay, that's what that means, which means f of g of x. Now this can be a little bit trickier. So we want to know f of g of x. So start with the inside. The inside function here is the g of x. So what I really want is I want f of 2x plus 3. I took out this g of x and put in that. Okay, well I can go now to my f function, and everywhere there is an x, I'm going to put in 2x plus 3. So I'm going to write f of 2x plus 3 is equal to 2x plus 3 squared plus 3, take out the x, 2x plus 3 minus 1, which is equal to, now you got to be able to FOIL that out, and if you can't, then write it twice and do FOIL. It's 4x squared plus 6x plus 6x, so plus 12x plus 9. Now we're going to distribute, plus 6x plus 9 minus 1. Combine like terms, and we will get f of g of x is equal to 4x squared, 12x and 6x plus 18x, 9 and 9 is 18 minus 1 is 17, plus 17. Now we need the domain. So let's go first to the domain of the inside function. The inside function is the g of x. I can't tell so much when it's written like this, but I can tell when it's written like this. The domain here, is there a restriction? No. This one has no restriction because there's no variable in a denominator and there's no variable under an even root. So there's no restriction there. Now look at the final function. Is there a restriction on the final function? No. For the same reason. Therefore, the domain of f of g of x is all real numbers, or negative infinity to infinity. There was no restriction. All right, I'm going to turn the page. I'll write the functions again so we can see them. F of x is x squared plus 3x minus 1, and g of x is 2x plus 3. And let's go to part B now. Part B says to find g of f of x, which means g of f of x. So I want g of, now write the f of x in there, x squared plus 3x minus 1. Now I have to go to the g function, and everywhere there's an x, I'm going to put in x squared plus 3x minus 1. So that's equal to 2. Take out the x, put in the x squared plus 3x minus 1, and then plus 3. I just followed my g function. Distribute that 2, and you get 2x squared plus 6x minus 2 plus 3, or g of f of x is equal to 2x squared plus 6x plus 1. Now, are there any restrictions? What's the inside function here? Inside function is f of x. So look at f of x. There's no restrictions there, and there's no further restrictions. Therefore, the domain of g of f of x is all real numbers. Okay? Let's look at a harder one. Let's look at example 3. Here we have f of x equals 1 over x plus 2, and g of x equals 4 over x minus 1. Well, before we even start, let's do the domain restrictions for each of these. So the domain restriction here, what is it that x can't be? Because it would cause a 0 in the denominator. X cannot be negative 2. It's easy. You can do it by inspection. Here, x cannot be 1. So we kind of have that out of the way. All right, so let's go to part A. And these get tricky. We want f of g. Notice this time it's just written like that. But what it means is f of g of x. So we want f of 4 over x minus 1. So which is our inside function? It's the g of x. The g of x is inside. So I already know that my domain is going to say x cannot be 1. Okay, because that's my inside function. Now, how do I do f of 4 over x minus 1? I go back to my f of x function, and everywhere there is an x, I'm going to take it out, so this right there, and put in 4 over x minus 1. So I have 1 over, take out the x, put in 4 over x minus 1, and then plus 2. All right, you've got to know how to simplify that. That is a method 2 complex fraction. And in order to simplify it, we multiply every term by the LCD. And the LCD here is x minus 1. So I'm going to put each term in parentheses, and I'm going to write x minus 1 outside of those terms. Those cross cancel. So f of g is equal to, let's see what we have. We have 1 times x minus 1, over 4 plus, go ahead and distribute, 2x minus 2, which is equal to x minus 1 over 4 minus 2 is 2, 2 minus 2x. That's what f of g is equal to. Now we have to talk about that domain. So, the domain of the inside function, remember that's step 1, the inside function was right here. X cannot be negative 1. Are there further restrictions on the final composite function? Yes, there are, because what we know is that the denominator, 2 minus 2x, can't be equal to 0. So if we solve that, we get negative 2x cannot be negative 2. Divide by negative 2, and we get x cannot be 1. Well, that's the same thing that, oh, did I do that correctly? No, I made a mistake. Hope you caught it. It was right here. That should have been plus, so that should have been plus, so that should have been plus, and that was plus, and that was plus, so it was a negative 1. Sorry. Easy to make those mistakes. All right. So the domain of the composite function, those are the two we care about. The domain of the composite function is x cannot be negative 1. The domain of the inside function was x can't be 1. The domain of the composite function is x can't be negative 1. So what is my final domain? My final domain is the set of all x such that x does not equal negative 1 or positive 1. Here was my inside function restriction. Here is my composite function restriction. So this is the final domain. Okay, let's try B. B, we want to know what is f of f. And that means f of x. Well, f of x, go back to f of x, and f of x is 1 over x plus 2. So we want f of that. So I have to go back to f again, and everywhere there's an x, I'm going to put in 1 over x plus 2. So that's going to be equal to 1 over, take out the x, and put in 1 over x plus 2, and then plus 2. Kind of weird, right? Kind of weird here. It is another complex fraction. The LCD is x plus 2. Let's put each piece of that complex fraction in parentheses and multiply by x plus 2, x plus 2. Those cross cancel, which was the whole point. So f of f is equal to, here I've got, distribute the 1, x plus 2 over, down here I have 1 plus, distribute the 2, 2x plus 4. Now let's see if I can do this without making a sign error, which is x plus 2 over 5 plus 2x. And now we need to talk about domain. So first, what was the domain of the inside function? Well, what was the inside function? In this case, the inside and the outside were the same. So the inside function here is f of x. So go back to the top. There is its restriction. X cannot be negative 2. Now we need to know the domain restriction of the composite function. So what I have to do is look at what I got right here. And I know that 5 plus 2x cannot be 0. So I'm going to subtract a 5. And I get 2x cannot be negative 5, divide by 2, and we get x cannot be 5 halves. So that restriction is x cannot be negative 5 halves or negative 2 and 1 half. So how do we write the domain? So the domain of f is the set of all x such that x does not equal negative 5 halves or negative 2. You just put them in there. The inside function, the composite function, restriction. Requires some work, but once you get the hang of it, it's not that difficult. All right, let's look at example 4. It says, if f of x equals 3x minus 4, and g of x equals 1/3 times x plus 4, show that f of g of x equals g of f of x, which equals x. Now this is interesting. These are, we're going to learn in the next section, these are special functions related to each other. I'm not going to tell you what they are yet. But we first need to find f of g of x, and then we're going to find g of f of x. Okay, f of g of x means f of g of x, write it just like I did, okay, which is f of, now go put g of x in there, 1/3 x plus 4. You don't need to distribute it, okay? F of that means go to the f function, and wherever there's an x, put in the stuff in parentheses. So that would be equal to 3, that's this 3, take out the x, put in 1/3 x plus 4, and then minus 4. All right, we need to do some simplifying. That's equal to 3 times, I'm going to distribute that 1/3, and that will give me x plus 4 over 3 minus 4. Those cross cancel, and I have x plus 4 minus 4. So f of g of x is just equal to x. Okay? Now we have to show that this is the same thing. And if it is, then those two functions that we started with have a special relationship. So g of f of x means g of f of x, like that. So g of, now write your f of x, 3x minus 4. Okay? Now go to the g function, that's the outside function, and everywhere there's an x, put in 3x minus 4. So that would be equal to 1/3, parentheses, take out the x, write 3x minus 4, now write plus 4. Okay? So that is equal to 1/3 times 3x minus 4 plus 4 cancels. Those cross cancel, and g of f of x also just equals x. And because of that, again, you're going to see what those functions are and how they are related to each other. So kind of remember this when we get to the next section.